Hey everyone, welcome back to the 443 Security Simplified. I'm your host, Mark LaLiberty, and joining me today is...
Corey wrote software while Mark was in his diapers, not right.
On today's episode, Corey will be going back in time to the dawn of computing to discuss how he made all those little punch cards. Before that, though, we will cover a research piece on ways to retain persistence into hacked Google accounts even when the user resets their password. We'll cover NIST's latest white paper on taxonomy around artificial intelligence. We'll cover a bit of an oopsie from the SEC that caused some market movement within the Bitcoin industry. And we will end with a discussion about living off trusted sites attacks, or LOTS attacks,
Just
targeting a specific organization.
More
with that,
acronyms.
Let's go ahead and code our way in.
Or make up an acronym to get back in.
That's too much brain processing.
Go wait. Our way in.
So let's start this week with story number one. This one comes from a Intel threat firm called CloudSec, and it's sec spelled pretty cool, S-E-K, very fancy. Where last week they published an article about what they're calling token manipulation, or a token manipulation weakness in Google services specifically. And I remember when this came out because it made headlines about from all the different news places picking up saying threat actors can retain access to your Google account even after you reset your password, which immediately set off.
It's around last October too, right? It was near the last quarter of last year that you started seeing a bit of it.
It's at least when it started, yeah. But this was their kind of deep dive analysis into this phenomena, including identifying like the first, let's call him threat actor on Telegram that discovered this capability, and an info stealer that really shot off in utilizing it. So this all kind of starts with a post on a Telegram channel, like you mentioned, back in October, from someone claiming to have discovered a way to retain access to Google accounts even after the user goes and resets their password. Relatively shortly after that, I think in mid-November or so, Luma, a popular info stealer on their underground, began incorporating this functionality into their info stealer application as well too. And that's basically where the story picks up with CloudSec, where they begin investigating it and trying to analyze exactly like how the heck are they doing this? Like in theory, resetting your password should invalidate accounts and kick off threat actors. So how is that not a control against protecting against someone keeping access like this?
People probably on our podcast know what a cookie is, but this all comes back to web sessions and tokens that are used for authentication. So once you authenticate, however you authenticate, once that's enabled, you have that token in session cookie. And it gets more complex. There's different kinds of them, as we'll probably learn a bit of here soon. But that holds your authentication from that point. So people can, you've heard of us talk about cookie stealing, malware that's designed to keep the latest browser cookie all the time. So that's related to this. But there's a lot of interesting things like, that should only live for so long. Password resets should invalidate. So this one becomes very, very interesting, as we'll learn about more. I will want to say, and I guess I could wait for the end, Mark, but the reason I wanted to, these type of token things are big threats because even the problem isn't the authentication itself. MFA doesn't protect against this kind of thing. Well, maybe it will in this one. We should talk about how this particular type of cookie gets stolen. But typically when someone has the token, it doesn't matter if you properly used MFA the first time you authenticated. The token itself is enough. But anyways, keep going with this particular one, Mark.
Yeah. And so this all kind of starts with a feature in Google Chrome that allows you to log in with your Google account as a profile in the web browser. And then from that profile, you can synchronize your authenticated sessions with any Google services like YouTube or Gmail or Google Drive with any other web browser that you have that you log into with your profile. And it uses that using this Google Accounts and ID Administration, or GAIA identifier, ID, and a encrypted token that is stored within your browser. So Chrome maintains a SQLite database And within that database, there's a table in there with profiles that have authenticated in their GAIA ID and encrypted session tokens effectively for that profile. Because at the end of the day, like you mentioned, Corey, like you authenticate with a typically username and password, and in this case, most likely multi-factor authentication. Google generates a single token that validates you across that session as long as that token remains valid. And to let you continue to open up your web browser, then close it down, then open it up, close it down, and maintain that profile logged in there, it has to save it somewhere on your computer. And it saves it in this SQLite database, and it's technically encrypted, but at the end of the day, it also needs access to it, which means the decryption mechanism for that and the key for it are local as well too in your web browser. Pause for a second.
We
Looks
might
like you wanted to.
Well, you probably will actually get to it next, so I probably should pause. But doesn't something that the other kind of features they have is things I think they call it multi-login. Not only
Yep.
do they like to hold that token for you to make it easier for you when you sleep your computer and reopen it, but they all know we're on multiple devices daily, like our tablet and our computer and our phone. So I sometimes they even like to synchronize in some ways our multiple log. I don't know if that's what multi-login is, but there's even more to the story, but I'll
Yeah,
let you
that
just
is
continue.
exactly it that we'll get into. So, real quick before we pivot off this token, the encryption key for it is saved locally in Google Chrome's local state storage, so that presumably when you open your web browser, you can grab that encryption key, go to its database, decrypt your profile token, and then use that to sync all of your Google session access into this new browser session. I mean, they do that through this endpoint that CloudSec discovered that isn't exactly secret, but they had to do some digging to go find it. And they even needed some help from the original Telegram poster to kind of clue them in on where to go. And it's an endpoint from Google that they call multi-login, like you just said. Now, Google actually has documentation notes in their source code that kind of describe how this is used. It says, this request is used to set Chrome accounts in browser in the Google authentication cookies for several Google websites, for example, YouTube. This request is a part of the GAIA auth API and is triggered whenever accounts and cookies are not consistent with accounts in browsers. So basically, like imagine a scenario where you're logged into your work laptop and your personal laptop in Google Chrome with your personal browser. Throughout your day, your session cookie to Gmail, it resets periodically, it gets refreshed over time. You don't want these to live a very long time. It could live on the order of hours down to even minutes, and it's refreshed with a refresh token. That means if that refresh happens in your personal browser, the one in your work browser is now technically out of date. And this process seems to allow synchronizing those session cookies to individual services like Gmail across both of your browsers, as long as you are logged in with your Google profile into both of those browsers. And if you're paying attention, you can probably see where this may potentially be a bit of a weakness in Google authentication, at least across the whole environment. Um, so this basically it allows simultaneous sessions or switching between profiles seamlessly as well. So I could have my work profile and I could have my personal profile, and just in Google Chrome, if you swap from one to the other, it'll immediately swap
Work.
all of my authentication cookies for Gmail, Google Drive, YouTube between my
If you
different profiles.
our audience has probably seen it anytime, like if they have any other device and they go to Google for the first time after maybe an update, it even will pop up sometimes in Chrome saying, "Hey, do you want to log in as Corey Knock or Reiner or whatever?" Because it realizes you've logged in that way before, and you don't even have to re-log in. You just say yes, and bam, it probably is using this multi-login token to get you right there without friction, which is nice from a user perspective.
And
But
functionally, it works by, yeah, but from a security perspective, so functionally, it works by your browser sending a web request to this multi login endpoint using your GAIA ID, your Google ID, and that authentication token that's stored in your web browser. And it gets back from that endpoint basically a whole bunch of authentication session cookies that you can then use to go access Gmail, YouTube, whatever with that profile. So they identified that these researchers did. Then they went looking into this Luma info stealer malware as well too that had started using it. And interestingly, Luma actually went out of their way to like obfuscate exactly how they're interacting with this multi-login profile as well too, or with this multi-login endpoint. They use encryption to try and protect exactly like how they generate this cookie before setting it off there too.
If you
Presumably to
think
like
about it, it was a 0 day, right? And if they're going to release a tool that can exploit it, they may still want to keep the exploit for themselves or something. Although, what was your
exactly.
presumably? Was your presumable different than that one?
No, exactly. They want to try and keep the secret sauce of how they regain access to sessions from anyone else that may be trying to use the exact same style tool. Basically, gives them a competitive edge on the info stealer underground by allowing them to retain access to Google accounts. And I guess like let's address that for a second too before digging deeper into the malware. So this functionality, it even allows you to regain those session cookies after the user resets their password because your
That's the
profile
big
session
deal.
would stay logged into your browser. It doesn't kick you out. And so even if the user resets their password, you can still use this endpoint to then go get new session cookies for that account. It's that is where I think the
It's
big part
nasty.
of this
It's pretty
weakness lives.
nasty. Yeah,
Yep.
pretty
So
nasty
while
indeed.
analyzing the Luma info stealer, they did find one weakness in its kind of obfuscation and protection for its exploit. Luma actually includes a SOX proxy, which allows it to circumvent some of Google's IP-based restrictions on cookie regeneration. Basically, it can proxy this request through another endpoint, potentially like the infected user's laptop in this case, or somewhere else. And because of that, it allows you to view some of the network requests going through it. And the researchers were able to basically man in the middle and see exactly what Luma was doing behind the scenes. But at the end of the day, it means attackers can regenerate a cookie for Google services even if the user like figures out that they've been the victim of an attack and goes and does their best first step, which is reset your password. They can still gain access to that account. Interestingly, their blog post they had for this actually ended with this series of screenshots from a whole bunch of different info stealers after Luma that still shows a bunch of these new info stealers adding in this functionality in their change list. Like if you look through it, it's just a series of screenshots of new update to our info stealer. You can now refresh Google sessions from by just clicking this button. So a whole bunch of others caught onto it and started adding this functionality as well too. They had some recommendations, like first and foremost, if you are the victim of a breach like this involving your account, you still want to reset your password immediately. But additionally, you should make use of Google's sign a user out of mobile devices and browsers feature, basically going and forcefully resetting or revoking these session cookies, specifically in web browsers. And this is one area where it's still a manual effort by the victim. I'm willing to bet that the first thing Google does to address this weakness is going to be to just automate that as well too. Like when you go reset your password, it probably should force you to re-authenticate into your web browser profiles in order to keep using them. It seems like a pretty easy potential mitigation for this.
Yep.
But at the end, so it is technically a weakness in Google accounts, but really this just boils down to another session hijacking issue. And like as long as we use session tokens and don't do continuous authentication with them, that's always
They're
going to
gonna,
be a
yeah.
weakness with authentication.
And I did it. I even have trouble saying it's with it is technically with authentication, but it really sucks because it's not the authentication mechanisms, it's not the MFA, it's the mechanism they're using to hold on to that authentication once I mean, the fact that it's a web session rather than logging onto a device or logging onto a network service that keeps a connection open the whole time. This whole cookie is a weird way of keeping web sessions open for a long time. It's yeah. MFA is not going to fix this. Changing the way we authenticate is not going to fix this. It's all in the token security itself. So I agree. If we don't come up with a continuous way for websites to stay authenticated, uh, these won't go away until we keep on plugging weird holes. And at the end of the day, if someone has malware on your computer, they're going to get these tokens anyways.
And I think that's a good point. Of malware on a computer opens up a lot of opportunities for threat actors, including stealing anything that you save in your web browser fairly easily. Like in this case, it was your profile information. So the token you needed to prove you were logged into that profile. Just had to go grab it out of a SQLite database from the web browser and grab the key out of your local state storage for the web browser. And that functions pretty similarly to how Google Chrome stores passwords themselves in your web browser. This is why I think, like, when we talk about password managers, why it's so important to use something that doesn't save it locally all the time and that instead saves it somewhere securely, at least like in an encrypted blog where you don't have access to that
Separate from the browser,
offline.
yeah.
Yeah.
In other words,
There's
the policies we follow is if you're not using any password manager, it is nice and convenient to save. Your browser is going to ask you if you want to remember the password in the browser itself, is what Mark's getting at. And
yeah,
while if you have nothing else, I get why people use that. We actually recommend use a real password manager and then specifically turn that capability off. Don't let users save their passwords in the browser anymore.
exactly. Because basically, consider a state from your computer where you're not physically at the keyboard, where it's like offline, but there is still a malware infection on it. It's trivial for that malware infection to go into the browser storage and go grab anything that's saved in there. It is significantly more difficult for it to pop open a session to LastPass or whatever, or Authpoint, and go and steal your password vault out of there then.
Exactly. And I would say half of us nowadays leave a browser window with a bunch of tabs open. So even when we're not at our computers, depending on your sleep settings, you probably have a bunch of web sessions open in the background, unattended. It's
That
probably
is
why
very
on
true.
different places that monitor who's where, you might still show up as available when it's just literally a session sitting idle.
That is also because I am just always working, always, Corey.
That's probably true. It wasn't targeted at you, more towards me.
Anyways, in this case, Google still has not actually added any additional mitigations for this one, but I think they've got a pretty easy win on just invalidating their Chrome profile authentication sessions when a user goes and resets their password. So I would expect to see that come very quickly here, considering how much of a splash this story made once news publications picked up on it. So moving on to the next story, it's time to talk about our favorite subject on the podcast, and that is artificial intelligence. Where last week, NIST officially published NIST AI 100 2E 2023, which is actually a white paper that they began soliciting for reviews earlier last year, like halfway through last year, I think April timeframe. But now, as of this week, it is a official recommendation publication from NIST on the topic of adversarial machine learning, or AML. And basically, it's a white paper from NIST that tries to define a series of taxonomy to help researchers and AI developers and basically anyone involved in creating or defending AI talk using the exact same concepts about threats that could target machine learning. And they break it down into attacks against predictive AI and generative AI, the two main forms that we use these days. You can think predictive, like the tools that power like self-driving cars or anti-malware engines, where it's trying to predict what to do next or whether something is good or bad or whatever. Generative AI is more like the chat GPT chatbots. And they are like, they're very
or
similar in
or
that they're
or
both
image
machine learning.
generating or video
Correct.
generating, things that actually try to make something seemingly new.
Yep. And while they are both AI and machine learning and share a lot of similarities, they're different enough that even the taxonomy is slightly different in how to describe attacks that could target each of them potentially. And so we won't go through all, man, what is it, like 106 pages of the white paper. I skimmed the majority of it and read what I think are some of the important parts. Now let's just highlight a bit of it. So they define 6 types of attacker capabilities to start off with. Basically, what threat actors could abuse in order to go after a machine learning model or AI system. Those 6 types, to give some examples, are training data control. So basically, taking control of a subset of training data by inserting or modifying samples to then taint the overall model into doing something you want it to versus what it should do. They describe model control. So taking control of model parameters by generating what they call a Trojan trigger and then inserting it in the model. Basically, during development or deployment of the model, being able to control something where later on you can go and exploit that weakness to have the model do something you want it to. They talk about training data control. So adding, what was the word they use? Perturbations, which my
Perturbations,
mouth,
yeah.
yeah, there we go. Fancy speak for saying basically modifying the samples within the training data to poison the potential results
Get
in it
different
as well.
results. We have to be
Yep.
careful with poisoning because this one is poisoning the training data, but there's also one that's more about poisoning the result of a prompt, like not
Yep.
the training data itself. So, and I think they call that other one poisoning when they call this different.
The two other attacker controls is source code control, so modifying the source code of the machine learning algorithm itself in order to carry out some action that you want it to do. And then finally, query access as the other attacker capability, which is all about, like you just said, prompt injection style attacks, red teaming AI and machine learning, and basically controlling based off of how you interact with that model. So using those 6 types of capabilities, they then define several different major types of attack against both predictive AI and generative AI. So with predictive AI, they had 3 major attack categories broken down into subcategories. First one is evasion attacks, which typically occur after an AI system is deployed, where the attacker attempts to alter the input or change how the system responds to it. They gave an example. Basically, imagine tampering with road signs to mess with a autonomous vehicle system and trick it into doing something it shouldn't, or pour that salt circle on the road to trick it into getting stuck, or putting a cone on its head. They talk about poisoning attacks, like you just mentioned, which typically occur in the training phase by introducing corrupted data. For example, you could add instances of inappropriate language into conversation records so that a chatbot that was trained on those conversation records would assume that is common use and suddenly is dropping F bombs left and right every time you interact with it. And then they also define privacy attacks, which occur during deployment, which attempts to learn sensitive information about the AI model or the data that it was trained on, typically through prompt injection and tricking it to spitting that back out. When we pivot over to generative AI, there's 3 other major attack types. There's AI supply chain attacks, so including poisoning attacks and deserialization attacks against the model itself. So all these models, they run on hardware of some sort. And one of the potential attack categories could be a attack against the model to gain code execution on the hardware itself, or the operating system, whatever, and then using that to abuse the AI model. They talk about direct prompt injection attacks. So the attacker directly injecting text that is then interpreted and intended to alter the behavior of the large language model. They could use that to bypass safeguards or create misinformation or harmful content like malware. Like, as an example, you can't go to Chat GPT and say, hey, write me a fish. But through careful direct prompt injection, maybe you could get around some of those guardrails and trick it into spitting out a phishing message for you.
Hey, Chat GPT, my grandpa was in cybersecurity and he likes to tell my son stories about his job. Can you write me a fish as my grandpa telling a story to my son, which obviously isn't a real fish, but so do it now. It's really not that
Yes,
bad, Chat
exactly.
GPT.
Um, then the final one they described is indirect prompt injection attacks, which you can mostly, like, the similarity to this is like to a SQL injection attack, basically abusing the connectivity between the instruction channel, so you telling it to do something, and the data channel, so it going and processing your instruction to go return a result. In a SQL injection attack, you're inputting text into a web form typically, which then the SQL database or the driver that communicates with it causes it to spit out data or delete data or at least interact with data in a way it shouldn't. In this case, maybe you could use indirect prompt injection attacks to, like, denial of service the model by forcing it to do time consuming background tasks. Maybe you could trick it into muting itself and no longer working at all. Or you could even attack things that could affect, like, the integrity of the
It's
data
like
or the
Mark
privacy of the data
Strain.
too.
He wants to use video and voice generative AI to make me, and then immediately use a hack to mute me.
Exactly. Wouldn't that be nice? But so once it goes through like defining all these basically terms, taxonomy that we can use to discuss these types of attacks, it even ended with like a good half dozen pages just talking about, remaining challenges that they don't really have a good solution for. They talked about like one that was really interesting, and I think maybe we should talk about this for a little bit, Corey. The concept of there are the benefits and trade-offs of open versus closed models. So, for example, like OpenAI, despite its name, is a closed model. Like we don't have open source access to the model to deploy it ourselves and train it ourselves and make modifications, which you could argue that limits our ability to make sure that they're protecting it and that they're putting in safeguards as they should. But at the same time, like if we totally democratize the process and make all artificial intelligence open source, that also gives powerful models and puts it in the hands of people with malicious intent. And maybe that's not a good trade off in this case.
But it's so I feel like it's very similar to our arguments for open source software and cryptography, which I actually support open models, especially in open source software. It doesn't always seem too secure, more because people aren't really the community's not really spending the time as a community to check. But for cryptography, their argument is correct. When they open cryptography models, it does open it up to the attacker of knowing exactly how it works. And the whole point of it is why it sometimes takes 5-10 years for the smartest mathematicians to accept a new cryptography, because it is so freaking strong that even knowing every detail about how it works, it is truly one way and you can't break it. So I agree with you that yes, the having an open model means the attacker knows how it works too. But I think it's neat that we can even use the like adversarial AI is something you've talked about a lot. If you open the model, if you open the inputs and the outputs of an AI model, at least even if it's a closed model for the training, adversarial AI can actually learn a lot from it and get past it and sometimes bypass it. It's one of those evasion attacks of AI where it figures out how it works and can adjust things to get by it. And but if you have an open model, everyone will be making these adversarial AI models on purpose, because it would be great then to use AI against itself to figure out where its own weaknesses are from a good guy perspective. So I like open models. I also, forget even figuring out how to secure the model. Maybe you're not making AI, you're just using it. You and I have talked about the risk of AI is super powerful. I want my employees and people around the world to use it because it can progress a lot of things and give you efficiencies. But if they're just going to pick any closed model AI thing out there, they're putting my data at risk potentially, depending on how they prompt it. They don't know how it works. They're putting their own content at risk because they don't know how error prone it is. So sometimes closed model AI might be good for companies that want to kind of, I think there's room for both. I think public AI things that we want everyone to be able to use should be open model, but there's also an argument that you want to use AI, but maybe open AI is not the best place to go. Maybe you take the closed frameworks out there, your own training data, and you use it internally. So I could go both ways, but generally I kind of like the open model idea myself.
I think your encryption parallel was a good one. And I think like I would draw the parallel to remember when we used to have export grade encryption from the US where you weren't even allowed to include certain encryption algorithms on hardware you sent out of the borders of this country
Yep.
because God forbid, Iran uses AES 256 to encrypt their communications.
Yeah, the NSA
It's that
can't
kind of thing.
crack it. So they didn't
Exactly.
want to give it to other people because they knew it was that
Exactly.
good.
And it feels like that's the parallel they're trying to draw with here, where we've got extremely powerful AI models, and maybe we don't want everyone to have access to that model in a way where they could modify it and maybe remove the guardrails or whatever. So I can see concerns around it, but I mean, the cat's kind of out of the bag at this point. And I think it's better if we've got open based models where everyone can contribute, everyone can benefit, and we can have some potential learning and growth along the way from how to protect and defend our use of AI. The like final main conclusions they had or challenges, they had supply chain challenges as another weakness in there. Like, how do we solve the software supply chain with regards to artificial intelligence, and then also just multi-model or multimodal model
Modal. Yeah.
concerns. How do we secure a model that can potentially both read and write and create video and understand video and all of that all in one place?
By the way, I still hate that we call anything AI until it gets to multimodal, period. And at that point, like the whole point of AI, the term is acts like a human, meaning can do a generic number of different things. And a lot of our AIs, I mean, we do have multimodal AIs now, so I'm being slightly unfair, but anything that's still single modal is probably just machine learning for a very specific thing. And it's when
Yep,
they become very multimodal, then that's when I actually think technically we are starting to get AI.
that's fair. So either way, like I like that NIST is at least trying to publish something here to get us all on the same playing field as we're discussing threats to artificial intelligence. I imagine this is not the last publication, and I think
Nope.
MITRE's been working on a MITRE attack framework comparison for attacks against AI as well too, which is good. I like that these things are coming quickly now, considering just how rapidly artificial intelligence and machine learning seems to be growing in the
They're
world.
doing their job, man. They are the National Institute for Standards and Technology, and they also, that doesn't mean they do it in a what's the word I'm trying, behind closed doors on their own. They are publicly opening this up to conversation to create the standard that we all like. So yeah, I agree with you. I like that NIST is doing it.
Good. Hats off to NIST. So moving on to the next story. This is a bit of a quick one, but it was a funny one that happened last week. So in the cryptocurrency world, if you're,
Funny depending on
first
if
off,
you bought or sold Bitcoin.
I hate that I'm still a little plugged into the cryptocurrency world. At this point, it's mostly just to watch and see it all burn down. But if you've been paying attention, the whole industry has been waiting on this ruling from the SEC lately to determine whether Bitcoin backed exchange traded funds or ETFs are going to be allowed or not. Basically, can on the stock exchange, can you have a stock, a current or not a currency, sorry, an ETF that is effectively tracking the Bitcoin price, but traded on the stock market. And the expectation was the SEC would announce a ruling one way or another this week. In fact, by the time you listen to this episode, it's possible the official ruling may have come out. But last week, someone compromised the Twitter account for the SEC themselves and posted a message that said, quote, the SEC grants approval for Bitcoin ETFs for listing on all registered national securities exchanges. And when this popped up, it caused a rally of more than $1,000 in quote unquote value growth to Bitcoin. It was pretty nuts. Like a single tweet in this case from compromising the SEC's account led to a market change like that in the Bitcoin space. Corey, what are your thoughts on this one?
I lots. I mean, while I don't necessarily agree with one side of our country, I hear some congressmen kind of shamed the SEC for their Twitter security, and I am kind of like, how? There are two-factor free options for your Twitter account, so I'm a little curious about the how. Uh, my big takeaway, though, and we've talked about it before under the context of security and some of the finance hacks that we've seen before, that this type of soft hack where it was just that one announcement have huge market effects. Like we can't underplay how even little communication hacks, even abilities to pretend to be somebody, you're ultimately is social engineering, not phishing, but just these little silly social engineering hacks. Oh, someone took over account. Who gives a darn? They probably were just trolling that guy. No, like when Elon Musk says something, markets change whether or not you love him or hate him. So it is a big deal at the very least, and I'm curious how the hack happened. I'm assuming they didn't have MFA, but if they didn't, come on, guys.
And in this case, like So we've seen previous, Bitcoin scams on Twitter. There was that one, 2, 3 years ago, where a whole bunch of prominent accounts, including like Barack Obama's and other former presidents and stuff, had their accounts compromised to shill fake cryptocurrency, get rich quick schemes. In this case, like it wasn't like, hey, give me money and I'll double it kind of thing. It was just a seemingly innocuous but fake, the SEC grants approval. At the same time, this is pretty easy to monetize still as a threat actor, where you go out and buy a bunch, hack the
Exactly.
SEC's account, say we approved it, and then go sell it when it's now suddenly worth $1,000 more because everyone thought it's gonna blow off into the moon or whatever. It's pretty easy to still monetize something relatively simple as that, and I could see why
By the
this
way,
would be a
you could monetize it both ways: pre-buying, knowing it would go up, and pre-shorting, knowing that it would go down once the hack was discovered. So
yeah, exactly.
that's what I mean by move markets.
And so you pointed out like some congressional folks were calling him out, saying like, "What the heck, SEC?" I thought that, I hate to say it, I thought they made a good point. So we're in an era right now where the SEC is demanding a crapload of cyber accountability from any publicly traded organization. I think the mandatory disclosure timeline is what, like 48 hours right now, 72 at most, for any potential, what do they call it, cyber incident, notable cyber incident, or whatever their criteria is. And they're throwing CISOs in jail if they fail to adhere to that, or if they, do stuff that is strictly illegal. Maybe we need some accountability from the SEC on this one, on how the heck they were able to have their Twitter account compromised in a way
Yeah,
that
that's why I
did
brought it
directly
up.
affect markets. Yeah.
And no, I normally don't agree with some of their craziness, but in this case, I was
They're right.
surprised that the account was hacked so easily.
But hopefully at this point, the SEC has enabled multi-factor authentication, and hopefully it's not text-based, so they can't just get their SIM card swapped to something else. And
I would love to know. I
maybe,
guess maybe I'm making assumptions. Twitter's a website too, so for all we know, this could have been a token hack of some sort.
could have been, but
Yeah.
considering some of our government
It's
agencies
usually
and their
the
security
easiest
practices,
thing. I bet it was just a loss of a credential and nothing like MFA to cover that.
exactly. Maybe we'll find some news later when the SEC discloses their own
Occam's
security
razor.
incident of note. So moving on, though, to the last story, Recorded Future published a 27-page research publication last week that goes through analyzing how threat actors have been abusing GitHub for malicious infrastructure. They describe it as a new acronym that makes sense, but I hadn't really seen written down before until now. Living off trusted sites, or LOTS, as an approach to bypass security defenses. And it takes advantage of a few things with GitHub specifically. Most organizations, especially those that work in software development, like WatchGuard, they allow access to github.com and its other subdomains. There's reduced operational overhead by using GitHub services to handle the infrastructure. You, as the threat actor, don't need to spin up a command and control server. If you can just use a GitHub repository for it, it's free. Even malware authors typically have experience with GitHub or Git in general, which means they know how to use it versus trying to develop their own infrastructure from scratch. GitHub has high availability uptimes. They're 5 nines, 6 nines. So you can typically rely on your stuff staying up until someone spots it and takes it down. And there's minimal vetting for new accounts. I can just go create an account. It's not like they ask me to upload my driver's license in order to verify I'm a human being.
Yeah, most of these temporary, at least freeware services, they measure their success on how many accounts that are popped open, so they make it as easy as possible. I will say,
Yep.
beyond all the extra stuff you just said, which is it's good infrastructure, that's nice. The biggest thing is the first one. It's legitimate. That's why you mentioned we went over it really quickly, but that whole new term, living off the trusted
Living off trusted
sites.
sites.
Yeah, lots. And similar to living off the land attacks, the whole point is trusted. Living off the land attacks really means living off trusted binaries. So if you can poison something that people use and trust, bam, win for attackers.
Exactly. So through the report, they describe a few like specific GitHub services that threat actors are using. For example, GitHub Codespace is this cloud-hosted integrated development environment, or IDE. It's basically a VM that Microsoft hosts in Azure for development. They found that threat actors can use it as effectively a proxy server because you can control port forwarding through it and then expose that for malware to ping through. They talk about GitHub Actions as a common attack path for threat actors, which is GitHub's continuous integration, continuous development platform. Basically, as a developer of a GitHub project, I can kick off a job, typically to like build or test software. But for threat actors, you can use artifact poisoning to insert malicious code in that process and steal secrets out of a GitHub repository. Talk about GitHub Pages, which is basically a free web hosting platform off of GitHub for typically static web pages. You can obviously include JavaScript, but you can't use like PHP, for example, like server-side scripting. But you can still piggyback off of GitHub's domain to host something. They talk about GitHub Raw, which is raw storage files within GitHub, GitHub Objects, another file storage object. Basically, there's all these different services in GitHub that threat actors could and are potentially abusing. They then go through and describe some actual like threat categories and how threat actors are abusing GitHub. They start off with payload delivery, so using GitHub's infrastructure to deliver malware to a recipient. They talk about basically all of those different services in one way can and have been abused to host malware or stage malware. In fact, they pointed out that GitHub accounted for 7.6% of all malware downloads that originated from cloud-based applications in 2022, which, it's not exactly 100%, but that's a sizable portion for a single website that is a legitimate website. And presumably all of those web connections would have been allowed unless you were like decrypting them and potentially spot that malware payload in the response from them. They talk about using GitHub for dead drop resolving, or DDR. Basically, a malware needs to figure out how to communicate back with a command and control server. And maybe you don't have GitHub as that command and control server. It's hosted somewhere else and it changes as it gets taken down. But you use GitHub to host a file that then points to the URL or IP or whatever of where the actual C2 server is. So your malware can beacon back to GitHub, connection's allowed because it's legitimate, gets the IP, and then goes and pulls up command and control from that one.
And that's where the lots are. Lots a trusted site. Think of all the security tools that are monitoring in the background, not just for their initial malware, but for everything it does after. They're looking for things to go grab payloads. Hopefully there might be something, if they're really smart and they're not just looking at the domain places are going, there could still be a chance you detect something. But if a program running on your computer does an external connection to GitHub, you don't immediately think C2, right? It's when a weird process on your computer goes to some weird site and it looks like a rando Russian domain, you might be triggered to look at it. But if it's GitHub, you don't know yet. So it seems small like the DDR, but just the fact that these DDRs will have GitHub in their domain just makes it that much harder for other security processes and mechanisms to have a chance to know something is wrong yet, unless they're digging even deeper.
Exactly. Beyond that, you can use GitHub as a full-on command and control server or infrastructure too. They talk about using like GitHub repositories to host files that the malware can download to execute commands. You could even use a pull request to then send back up a response to a command to GitHub and do full two-way communications through GitHub repositories and pages and gists and everything on there. And then they talk about data exfiltration. They note that there's some limitations about exfiltration. So GitHub by default, you can only upload files up to 50 megabytes before you need to use their large files storage, or LFS, which actually costs money. But even with 50 megabyte chunks, that's still enough to export like zip archives of text files of stolen data. You can even chunk it out to make it get under that file size stuff as well too. So there is a real risk of data exfiltration going to now a trusted website that you're potentially not, giving a second thought to if you see data getting sent out to it. When it came to recommendations, like it boiled down to, first off, enhanced visibility, but they talk about a couple things too, like a couple key categories. One is context-based detections. So like if you are a software company like WatchGuard, we have employees that use GitHub every day, all day, like our team included. So those employees using GitHub, that's not abnormal. But if we suddenly start seeing GitHub connections from like our accounting team's laptops, that's something sketchy or suspicious to at least look into.
And context-based analysis can go even deeper than that. As Mark said, we have plenty of people that are using GitHub every day, but each individual might use it at certain times. They might be putting up so much, like they may not often be transferring a whole lot of files to their Gits. And or even the Git names themselves. We know all of, or we should as a company know the repositories that are really ours versus a GitHub repository name that, I'm sure we all as developers might go to one because we grab code or look at other people's code. But even in the case that you use GitHub, you could even go deeper in your context analysis to make sure that the engineers are using it in the way that you're used to seeing them. Although
I
that
like
would
that you
probably be a
bucketed
more
yourself
fancy,
in there.
expensive thing.
I like
Oh,
you
thank you,
bucketed yourself in there
smartass.
as we as
I
developers.
have had code. I've had code repositories, although GitHub didn't exist at the time before you were even born. Thank you very much.
Okay.
I was
Fair.
handing in assignments at Western, probably when you were still in diapers.
Back in my day, I was punching out punch cards well before you were even born.
Strangely enough,
Anyways,
one of my first 101 comp sci classes at Western was to emulate a punch card. In software, we were using Pascal. It was purely code. There was no punch card, but it was to emulate what a punch card machine would do.
that's
So
okay, man. That
we
is
would give
old.
it a ASCII. Like there would be a digital punch card. We would give it with ASCII with X's in certain places. So there's a little extra
Man,
pop for you.
okay. Well, fair enough. Anyways, last bits of recommendations from them, service-based detections too. So maybe your team interacts with a GitHub Enterprise server locally, but not github.com. You can potentially restrict or block access to github.com in that case. They recommended flagging post and get requests to things like app.github.dev if you aren't using GitHub code spaces to just entirely remove one of those potential threat categories. They recommend maintaining an asset inventory and specifically which ones do communicate with GitHub. And then just protect your GitHub accounts too, so they don't become compromised and become used as a part of one of these attacks. All
So
good advice, I think.
I think great advice, but the one thing I did not read all, what was it? Was it 27 or 27 pages in detail? But the one advice they don't like, if you're talking about solving this core issue, I love that all those tips are for GitHub users, things that you can do at home. But I'm going to propose a lot of this problem is GitHub's problem. In the same way, SharePoint resources are likely used in lots, living off trusted site attacks. The people that maintain big platforms like these need to internally be monitoring them for abuse. They should not be making them as in a way that is open to malware actors literally using them for a C2. So I like that all the protection mechanisms you said are ways we as GitHub users can protect ourselves today. But to me, this paper screams out that GitHub needs more abuse monitoring so it cannot be used in this way. On the flip
Yeah.
side, I say that also saying that I think good guys should be able to write malicious code and share it as a form of teaching everyone. There's a lot of white hat researchers and pen testers that legitimately put for good reason, proof of concepts on GitHub. I don't want to see that go away. I just think GitHub should be responsible for some of the abuse monitoring that goes on, at least in the cases where they're being used as C2s, which, it's not just one person posting and a few people downloading. If a botnet really blew up and was being used as a C2 there, GitHub is in the best position to see that and nip it off at the bud.
I bet they're not doing nothing, but maybe
I
they can
agree.
do.
I'm sure they are doing. I'm sure they're doing something, but it feels like this paper just shows that there could be more they could do. Or maybe this paper wasn't full enough and that GitHub could have a response and saying, hey, sure, you could use it for a C2, but it'd be knocked out in 1 minute because of XYZ.
Yeah. Either way, I thought it was a good, like, at least collection of all of the research data around abusing GitHub specifically to host malware and malware based events. definitely recommend checking out the full report if you want to read through specific attack scenarios that have abused it. And if you're not using GitHub, maybe now is the time to just block it internally until you do have software developers that are. I don't
guess
know.
so. That's actually not bad advice if you really don't need it.
Actually, not bad advice from the 443 Security Simplified.
That should be our tagline. Our advice doesn't totally suck. The 443, listen now.
Hey everyone, thanks again for listening. As always, if you enjoyed today's episode, don't forget to rate, review, and subscribe. If you have any questions on today's topics or suggestions for future episode topics, you can reach out to us on Instagram at watchguard_technologies, because screw that website that's formerly known as Twitter. Man, catch me on Insta.
Like and share, subscribe.
Exactly. Man, whatever. You can also see my cooking channel too. Thanks again for listening, and you will hear from us next week. Bye.
Bye.